Hello students, good evening all of you. How are you all? Right, I think almost we have come to the month of September. All are busy studying, preparing for competitive exams, CBSE, pre-board examination, some schools half-yearly examinations, and some are busy preparing for the NEET examination, or all JIPMER, all these. So here last week I have just sent a video based on mechanism of organic reactions. Now I picked up a very interesting topic today, that is mystery of reduction. What actually are these? We very well know in organic chemistry we have different types of agents, oxidizing agents also, reducing agents also, isn't it? Right? Why I have picked up this is, whenever you're writing a competitive exams or whenever you're writing a CBSE exam grade 12 or 11, the reagent which is present on the top of the arrow is the most important thing, which decides the type of product form, correct? Right? So I thought if I give you the different reducing agents, if I explain you what from where it is getting reduced to which one, what actually is the mystery of reduction, I thought I'll share it with you all students. So nice data, very informative data, very important thing. Take a book and keep noting it along with me, right? So basically when I speak about reduction, we very well know there are two processes. One is oxidation, one is reduction. So reduction is a process where there is always loss of electron, correct? Means when how loss of electron, if I have to say, when the reducing agent rule is nothing but it loses electron, correct? Now let us come back again, redo it. Whenever I speak about reduction is nothing but addition of hydrogen, correct, which will help me in reduction, reducing agent, right? So reducing agent, if I have to define, okay, reducing agent definition, first let us write that, then we'll understand. Basically your reducing agent is a substance, okay, right? It's a substance or a chemical species. What this chemical species or a substance, reducing agent is a substance. What does it do when it is present in a reaction? Now I said it is a substance. What will it do? It's going to lose, means a substance which tends to bring about a reduction process. So reducing agent is a substance which tends, means which allows to bring about, means what is its role, what is its job? When every reagent has a mode, every reagent has a job, isn't it? What to do? So reducing agent is a substance which tends to bring about reduction. Okay, now what is reduction? Basically is nothing but addition of hydrogen, correct? We are going to add hydrogen, done, right? So this reduction is addition of hydrogen, and by being, what will happen during this process of addition, the reducing agent do, it gets oxidized by being oxidized, okay, the reducing agent it gets oxidized, done. Or and also there is and it also loses electrons. Done, students? Okay, so I have got one idea. That means whenever reducing agent is there, it's going to add hydrogen. That reducing hydrogen, during this process it gets oxidized and it loses electrons. Now what are the different reducing agents which we have in chemistry? Let's list out all the reducing agents. Whatever are there, I'll list out. So the reducing agent, the common reducing agents which are listed here are, what are they? Lithium, aluminium, hydride. It is one reducing agent in ether. Okay, I'll be listing out all and I'll be giving you examples also in the next, for each and every reducing agent in my next video. Now let's see this first. Reducing agent, lot to learn today. Let's enjoy and learn it. So lithium aluminium hydride is one. Next, lithium borohydride is one more in ether. Next reducing agent is sodium borohydride in presence of AlCl3, Lewis acid. Next would be lithium aluminium hydride in presence of Lewis acid. Done. Next, one more reducing agent which we have is sodium borohydride in the presence of PtCl2. One more reducing agent which I wish to share with you all is sodium borohydride in the presence of alcohol. So keep listing, so many are there, right? Let me come back one more. One more reducing agent is B2H6. I think you've heard about B2H6. What is B2H6, students? It is nothing but diborane, isn't it? Yes. So this B2H6, let us write that. So B2H6 in what? B2H6 in presence of THF, tetrahydrofuran. After that, one more reducing agent which I'm going to list out is red phosphorus in the presence of HI. One more. Yes, I have loads of reagents to tell you. Reducing agents. Active metal plus acid. Active metal plus acid. What is that? For example, your zinc plus acetic acid. Let us write that. Active metal means zinc plus acetic acid is one reducing agent. Concentrated or here we'll write concentrated HCl is an acid and Fe is one more active metal. Then one more zinc plus HCl is one more. Right, let me list out one more reducing agent. Hydrogen plus nickel. Right, the next would be platinum or palladium. Right, yes. Now let us list one more. Okay, so many are there, isn't it? Right, one more reducing agent which I wish to share with you all is hydrogen plus palladium presence of charcoal. Hope students you are all noting it. Hope I am not going fast. If you feel it is too fast enough, you can reduce your settings also when you are watching the video. Right, next, one more reducing agent which I wish to share with you all is nothing but sodium aluminium hydride. Sodium aluminium hydride. Next reducing agent is alkali metal and alcohol. Okay, right. Next reducing agent is hydrogen P2 or P2 platinum oxide and or Adams catalyst, platinum dioxide or Adams catalyst. Okay, apart from this, what are the other we have? We also have different catalysts which are going to act as a reducing agent. I'll be showing you one after the other, like Linder's catalyst, Dibal is one more. Right, so different things we will be discussing. Now after I have noted this reducing agents, now I have to just see what actually are the different concepts or which one will get reduced to what. So keep noting, students. Very interesting one, very important for organic chemistry. Right, this is a mystery of reduction. You keep noting, you will enjoy it during examination. You can just go through the video. You can just remember, okay, aldehyde to this one, or acid to this one, alcohol to this one, cyanide to which, like that you remember for the exam and go. You will get complements. You can easily solve that within seconds. Right, so now the first one, remember always aldehydes on reduction they're going to give. So reduction, we put that addition of hydrogen here. So remember aldehydes on reduction gives alcohols. Okay, alcohols, what will happen on reduction? Alcohols will always give alkanes. Remember this is the sequence. Nice, isn't it? Now after aldehydes, let me take the next one, that is ketones. Ketones on reduction, what will they give? Ketones on reduction again will give me alcohol. Alcohols on further reduction, what will they do? They give alkenes. Over, students. Now let me come back to the next topic, that is alcohols now. Right, alcohol, suppose if you're using the reducing agent, you're going to add hydrogen to this. When alcohol undergoes a reduction, it's going to be converted into alkenes. That is what we have written here, isn't it? Done. Now suppose if I have, or if I am given isocyanide is given to me. Okay, isocyanide is given, I have to perform a reduction process with this. So this is isocyanide is going to give me secondary amine. Okay, suppose ma'am, if I am given cyanide, what will I get? If you are given cyanide, that is RCN, if you are given RCN, if reduction process is performed with this, what do I get? I get primary amine. Remember this. Done, students? Okay, interesting, isn't it? Now aldehydes is over, alcohols is over, ketones is over, cyanide is over, isocyanide is over. Right, so I have to do slowly acids also. I need to do acid chlorides also. Let us do that. Now suppose if I have acid chloride, RCOCl, acid chloride is with me, and if I perform this reduction process, what product will I get? I'll be getting aldehydes. I'll be showing you with the reactions also, one after the other, gradually in my as I complete the topic. Aldehydes, as I told you, aldehydes, what will happen on reduction? They give alcohol. Alcohol on reduction gives alkenes. Same thing I'll be writing. So aldehydes on reduction gives alcohol. Alcohol on reduction gives me alkenes. This is over. Yes. Now, in case of Rosenman reduction, suppose, can be stopped here in Rosenman reduction. I will stop the reaction here only. Now, next thing. What is the next thing? Ester. Suppose if I have ester is given to me, I do the reduction process using reducing agent. What product will I get? I'll be getting alcohols. Now again, we very well know alcohols on oxidation always, alcohols on reduction always gives you alkenes. I am again stopping at alkenes. Done, students? Now, after ester, if they give me cyclic ethers, suppose cyclic ether is given to me. So this cyclic ether, if I perform reduction process, what will I get? I get an alcohol. Remember, this alcohol can be primary or secondary alcohol. Now, this alcohol further on reduction, they're going to give me alkanes. As we very well know, alcohols on reduction gives me alkanes, right? So, you have to know this, students. Alcohol on reduction gives me alkenes. Done. After this, what is the next one which we are going to learn? After cyclic ether, let me turn the page and note what is the number. We have left it 8. Now, let me come back and see. In the 9th topic, now nitro is over, cyclic is over, ester is over, acid chloride is over, aldehyde is over, ketones are over, alcohols are over, correct? Now what else is there? The next, let me come back, nitro compound, right? Nitro compounds, if I have to take, right, let's say nitro compound, if I take and if I introduce, means I take the reducing agent and I start perform the reduction process, correct? We said, right, reducing agent, it helps in the addition of hydrogen and it itself gets oxidized. So nitro compound, when it undergoes the reduction process, what product does it give? It's going to give a compound called a nitroso compound. This nitroso further, when we reduce it, it's going to form hydroxylamine. Hydroxylamine further on reduction gives me primary amine. Done, students? Yes. Now let me come back. Let us learn some more. Suppose if I have alkyl isocyanate. Okay, one more combination, alkyl isocyanate. How do I write alkyl isocyanate? I write alkyl isocyanate R N iso, no, N double bond C cyanate double bond O. Suppose if I allow it to undergo reduction process, what do I get? Now R N C double bond O. See here, one hydrogen adds here, addition of hydrogen, 2 hydrogens adds here, 1 hydrogen adds here. Total number of 4 hydrogens. 4 hydrogens add here. How? R N. This double bond is broken. Here also double bond is broken. You get RNH CH2OH. Now further, if I have to perform reduction to this, I'll be getting secondary amine. Secondary amine. Done, students? Yes. Suppose if they give me, right, if they give me an oxime. What is oxime? Basically oxime, the formula is R. Now if I take the example, general example, R2C double bond NOH. This is oxime. This oxime, if I have to perform the reduction process, where will the hydrogen add? It will break the double bond here, okay, right? So here there is double bond, here also there is cleavage of the bond and attachment. That means there is one hydrogen, there is a cleavage of the bond here, there is a cleavage of the bond here, one hydrogen adds here, one more hydrogen adds at this point, one more hydrogen adds here, and one more hydrogen adds here. What do I get? I'll be getting R1, R2, C, H I set 1, NH2 plus water. Water cleaves out. Right, students? Easy. Right. Now, so what is it converted? Oxime is getting converted to primary amine. Primary amine. Now, let's come back and see some more examples. Let me do this. Hope the video is clear, students. Right? And keep noting it. Yes. Now further, suppose if I have to take, now let me try with a different reducing agent again, reduction of triple bonds and double bonds. Let's see, let me take out oxime and come back. Suppose, what is the number? 12. Now suppose if I have triple bond is given to me, right? Basically I have to, means in the question triple bond, an alkyne is given to me. Whenever an alkyne is given to me, what is that? It's unsaturation compound with triple bond. this alkyne, because you have one bond to break, one more bond to break, and I'll be taking two hydrogens, because one here, one here. What will I get? Triple bond. First step, it is converted into double bond. Okay, it gets converted to double bond. Then double bond. Further, when you cleave it, again two hydrogens, because this is double bond, right? It will get converted into single bonded compound. Single bond. That is, this is alkyne, this is alkene, and this is alkane. So always remember, on reduction process, alkyne gets converted to alkenes, alkenes get converted to alkenes, right? Suppose if double bond is given to you, what will happen? No, you should only tell me, students. Now alkene is given. Let me take one example. Suppose R1 CH double bond CHR2. Now this is an alkene, isn't it, with two different alkyl groups. I need to add reduction process, that is two hydrogens, right? So what will happen? This is broken here, correct? One hydrogen adds here and one more hydrogen adds here. What do I get? Alkene, it on reduction becomes alkane. What is the formula? R1 CH2 CH2R2. This is an alkane. Now let me come back to the next one. Suppose if I have aliphatic halides, okay, it's a reduction of halide compounds. So if I have Rx, what is this? This is called alkyl halide or aliphatic halide. This is called aliphatic halide. So aliphatic halide, what will happen when you add or when you perform reduction process to this, right? Two. One hydrogen adds here and one more, means there is a cleavage of the bond. This is aliphatic halide, there is a cleavage of the bond, and it will become a hydrocarbon plus HX. Suppose if I have an aromatic halide, same thing. Aromatic halide is nothing but the aromatic compounds, the benzene ring with X. What is this compound called? This is called aromatic halide, right? Suppose if I take aromatic halide, if I do the reduction process to H, what will I get? Again, there is a cleavage of the bond here. Yeah, one hydrogen adds to this benzene ring, one more hydrogen adds to this X, right? And what do I get? I get ARH plus HX, right, students? Clear? Yeah. Suppose if I have to reduce, if I have a carboxylic compound, RCOH, means there is an acid. Acids on reduction, remember, I'm going to add, listen, always acids on reduction, they get converted to aldehydes. Aldehydes on further reduction, they're going to get converted to primary alcohols. Primary alcohols on further reduction, they're going to get converted into RCH3, right? So, and we said alcohols in the first page only, we said, isn't it? What did we say? Alcohols on oxidation gives alkanes. So aldehydes on reduction gives alcohols, alcohols on further reduction gives me alkanes, right? Now let's further see some more reactions, very important in the mystery of reduction. This is over. A lot of information is there, isn't it, students? Now let us write the 17th fact of this, 17th mystery, right? In the 17th mystery, suppose if I have to reduce alkyl or aryl azides, so let us write reduction of alkyl or aryl azides, means if these compounds are there. Now what are alkyl or aryl azides? Let's write that and check. Now basically your alkyl or aryl azide, how do we write? It is nothing but azide, means and this is a compound, right? Now this one, first when you heat it, means it will lose nitrogen, right? Further it gets converted to nitrene. First it gets converted to nitrene. After this, on further reduction, now what is nitrene? Nitrene is nothing but R and 1, 2, 3, 4. Okay. On further reduction, nitrines get converted to primary amines. What is the formula for primary amine? RNH2. Because I am adding hydrogen to this, two hydrogens will be added around nitrogen. Yes, students. This is over. Okay. Now after alkyl or aryl acid, let's see acid-amide. Suppose if I take the 18th fact, if I take reduction, let me underline this. Right, now let's see the next one, that is the 18th fact of the mystery of reduction. So when I take the 18th fact, now what are we going to see? We're going to see the reduction of acid-amides. Reduction of acid-amides. What actually are acid-amides? Let us write that. Acid-amides. Acid-amides are nothing but R C double bond O NH2. This is acid-amide. Right. Suppose this acid-amide, if I have to perform the reduction process, what will it get converted? We know reduction is nothing but addition of hydrogen. I'm going to add 2 hydrogens. Where will that add? This is going to shift. 1 hydrogen shifts here to this oxygen. Right. 1 more hydrogen shifts here to this carbon. Right. What do we get? R C single bond OH. Carbon is with hydrogen, next is NH2. Right. Further, when I still allow it to undergo reduction process, during this process what happens? 1 hydrogen adds to this, 1 more hydrogen adds to this. During this process there is removal of water. What do I get? I get a compound, there is a cleavage of the bond here, R CH2 NH2. What is this compound? This is nothing but primary amine. Correct, students? Now the same acid amide, suppose if I take an alkyl amide, let me write the 19th mystery, that is nothing but reduction of N alkyl amide. Okay, what is N alkyl amide? R C double bond O alkyl, we have written it right, so NH1 instead of 1 hydrogen, R2. Now the same process, if I means the same process will be there here also followed, right? And so when I add further this is 2 hydrogens, 1 hydrogen will add here, 1 more hydrogen will add here. Let us write R C OH CH NHR2. Further, I am going to add 2 hydrogens to this. Here, removal of water. 1 hydrogen adds here, 1 more hydrogen adds here. There is a cleavage of the bond. I get R CH2 NR2. Because there are 2 alkyl groups here, 2 plus 1, 3 alkyl groups here, we call this as primary amine and we call this as secondary amine. Right, students? Right. So this is called secondary amine. Secondary amine. Right. So let's come back and do the next one. Primary amine is over, secondary amine is over. Now further, if I have to take the different reducing agents or which acts like different catalysts which act as a reducing agent, what are the different one? We have Lindlar's catalyst, we have hydrogen palladium carbon catalyst, Dibal, we have lithium aluminium hydride. Right, students? Like that. Now let us come back and do that also in the next category. What is the next one? When I take the next category of Lindlar catalyst, now just let us write the first one. Okay, what was the last? I think we have stopped at the 19th mystery. Now, next one. If I have to take the next important thing, right? Lindlar's catalyst. Right, students? Lindlar's. So here 20th mystery. Lindlar's catalyst. Lindlar's catalyst. So Lindlar's catalyst, whenever there is Lindlar's catalyst, remember we very well know what do? We take the Lindlar's catalyst, then we are going to we are going to poison, means poisoning will be done. Poisoning can be done using lead, calcium carbonate or barium sulfate and quinoline. Correct? What is actually the role of barium sulfate here? Along with calcium carbonate, what happens? It supports, means it acts as a supporting system for the reducing substances. That's why we poison it. Right. So whenever there is Lindlar's catalyst, what will happen? In the presence of Lindlar's catalyst, remember, alkynes, they get reduced to alkenes. Hope students you are understanding this. I'll be showing reactions also in my next video. Please keep noting, because basic thing, if you understand this, it's easy for you all. So in the presence of Lindlar's catalyst, alkynes, they get reduced to alkenes. Then RCOX, that is your acyl halides, they get converted to aldehydes, RCHO. Suppose 21st mystery. Suppose if you have hydrogen plus nickel, or if you have hydrogen plus Raney nickel, if you have this on the top of the arrow, what you get? Triple bond breaks up into, in the presence of this catalyst, triple bond, it will break up into double bond. Okay, double bond will break up into single bond. Remember this, double bond will break up into single bond. Fine. Suppose if I have the 22nd mystery of reducing agent, suppose if I have a catalyst like this, what is that? Hydrogen plus palladium plus carbon, that is your charcoal, right? So here if I have these reagents, what will happen? Just see, double bond, it will get, means it will break or it will get converted into single bond. It means it will not, remember here triple bond is not included, it will not go, means it will not work at the triple bond point. Here only double bond to single bond. Right students? Yes. Now let's see further. Is my lens clear to you all, students? Let me make it clear. Little bit adjustment I need to do. I'll just do it. Right, double bond to single bond. Right, so let me come back and do little more. After this, what is the other thing which this catalyst works, which it acts as a reducing agent for which one? During the presence of hydrogen, palladium and charcoal, nitro group gets reduced to amines. Remember this, cyano group gets reduced to CH2NH2. Azide gets reduced to primary amine. Right? If I have to take alcohol, means which alcohol? I'm going to take benzyl alcohol. It gets converted to toluene. This is toluene, isn't it? This is about your hydrogen, palladium and charcoal catalyst. Let me take the 23rd fact of your reducing agent. I am going to take now 23rd, that is your 23rd reducing agent, that is dibal. Right, what is dibal? Dibal H, that is nothing but di-iso. D stands for di, isobutyl aluminium hydride. Di-isobutyl aluminium hydride. Whenever there is dibal present, di-isobutyl aluminium hydride, it's going to act, or it's going to convert, or it will allow esters to get reduced to aldehydes. In the presence of dibal, cyanides, they get reduced to aldehydes in the presence of HCl. Okay, always remember, whenever dibal is there, dibal will not reduce triple bond or double bond. Remember that it will not reduce triple bond or double bond. Remember this, never. Suppose if I take the 24th mystery, that is lithium aluminium hydride. So lithium aluminium hydride, in the presence of this, esters get reduced to alcohols. It's going to reduce all type of those groups, means which has C double bond. Remember, whenever there is lithium aluminium hydride present, you have to remember the concept that it's going to reduce the compounds which have C double bond O, means wherever there is C double bond O group is present, all this lithium aluminum hydride group will reduce. What are the C double bond O groups? Basically R, C double bond O, R. This will get converted into R, means this bond is going to break. One hydrogen will add here, one more hydrogen will add here. R, CH, OH, R, like that. Right, students? So it's going to, wherever the C double bond O group, it's going to break that, means it's going to form the compound. Now let me see one more group. Suppose if I have R, C, OH. If I have lithium aluminum hydride, this bond is going to shift here, hydrogen goes and adds, one hydrogen adds here, right, this gets converted to RCH2OH. Suppose if I have RCOCl, see everywhere there is C double bond O group. If I have lithium aluminum hydride in the presence of this as a reducing agent, here also lithium aluminum hydride, again this bond going to shift here, hydrogen. So what do I get? RCHO. Right, students? Right. Suppose if I have R, C double bond O NH2. Lithium aluminum hydride is here. This bond is going to shift. It gets converted to R, CH2 and H2. Hope students you are understanding. You're noting along with me, students. A very important concept of reducing agent. Done. Now, after this, reducing agent. Which number is this? This is almost 24th. Now, let me take, after lithium aluminum hydride, I'm going to take sodium borohydride. So the 25th mystery of reducing agents. In sodium borohydride as a reducing agent, what is it going to do? In the presence of sodium borohydride, aldehydes are getting converted into alcohols. Ketones are going to get converted to, this is primary alcohol. Ketones are getting converted into secondary alcohols because two alkyl groups. RCOCl, that is CO 1 2 3 4, right? Double bond O. Okay, I should not put this because RCOCl, correct. Acyl chloride, they're going to get converted to alcohols. But remember, sodium borohydride will never reduce, or it will not work with triple bond or double bond. Remember this, students. So this is just from my side, students. 25 mystery facts I've given about reducing agent. I'll be listing out, I'll be doing reactions also gradually, so keep noting. I think all the 25 mysteries of reduction or the reducing agent, your concept is clear. Keep noting it, students. I'll meet you again with one more session of interesting reactions involving all these reducing agents. Thank you for watching. Stay connected, stay happy, stay blessed.